Hello and welcome. My name is Louis Cataldi. I'm an education evangelist with Epic Games. Today we're doing a crash course, an introduction into Unreal Engine. We'll take a look at a number of key features of the engine and take a look at how they work. Let's get started. Let's begin by taking a look at the project structure of Unreal Engine. The project structure of Unreal Engine can be thought of as a project which contains levels, and levels can contain sublevels. They certainly don't have to, but they certainly can. But levels are typically filled with actors. And actors is a naming convention we use for anything that can be placed inside of a level. And an actor typically has location, rotation, scale, and sometimes mobility information for the actor specifically placed. And actors can have components of different types. A static mesh actor can have the static mesh component, and it can also have components like material components or elements, and a variety of other components that are related to the actor. Now, when you create a brand new project in Unreal Engine, you're met with the interface that helps you to choose what you want to make. If you're working on a game project, you have templates that help you to choose what types of game you want to make. Same thing with film, television, and a live event, or architecture, engineering, construction project, automotive, production design, or manufacturing. You're encouraged to choose either whether you're going to make a blueprint-based project or C++. It doesn't really matter if you choose one or the other. You can always change your mind or integrate C++ into a blueprint project or blueprint into a C++-based project. You can choose a template or you can pull one in later in the project. You can choose your target hardware, whether you're going to go for a mobile type project or a desktop. And then if you want to choose some starter content, whether it's some static meshes or particle systems, or even some blueprints and additional maps to help you get started, you can do that. And you definitely want to choose some good naming convention. I've included a link here below, which can give you some really good examples of proper naming conventions for both the assets and folder structures to help you get started. Now, when you are working inside of the levels inside of Unreal Engine, which is the proper naming conventions for what you're looking at inside of the viewport, you can always start with the levels that you start with at default, but you can always create a brand new level. And you can see that we can start with a completely empty level when you create a new level. Or you can use the default level, which gives you a platform and a skybox, and a sky sphere to work with. You can use the new time of day system, which is a beautiful system with a sky atmosphere, or a basic VR level, which gives you some physics assets and some environment settings that are optimized for virtual reality. Now, an actor is basically anything that you can place inside of a level, and these can include things like sound actors, static meshes, skeletal meshes, blueprints, and actor class blueprints can be anything that you can place into a level. Cameras, lights, any types of volumes, including blocking volumes or collision volumes of different types, or even trigger volumes, and many more different types of things, as you can see from this list, are considered actors. Now, if we take a look at the user interface for Unreal Engine, this is a typical default user interface where we're met with a viewport. Inside the viewport is all of our actors, and we're looking at the level here. To the right, you can see the World Outliner. That's number 5 on our list here, and our World Outliner is basically a one-to-one representation of what we see inside of the viewport in our details panel below the World Outliner. Now, these three all have a contextual relationship. So if you select, for instance, the chair in the viewport, it will be selected here in the World Outliner, and that's what's represented in the details panel as well. The content browser in the lower part of the screen is where you can actually have content that you import inside of Unreal Engine, as well as anything that's created. If you create materials, if you create blueprints, if you create Niagara systems, if you create sequences, animations, all that stuff can be stored or imported, textures, materials. This is basically the library of content that you're working from your project with. Over here on the left side is your placer actors, or your modes panels, a variety of different panels that you work with that are your modes in essence. And here is where you get content from in-engine. So if you wanted to use primitives, if you wanted to place a player start, if you wanted to grab a light and place it into the scene, you see that we have subcategories on the left side. So there's an actual light section where you get all your lights, your cinematic actors, visual effect actors like fogs and reflection actors, different types of geometries and volumes. And there's a search bar because there's quite a bit of engine content that you can access. And if you aren't sure where to get it, one of the best ways to get it is by searching for it. Then we have a toolbar at the very top here as well. And some of the really important content that you access through here is access through the settings drop down, where you get access to the world settings. This is also where you have your build menu for building lighting and building reflection. This is your cinematics drop down where you have access to things like sequencer. And this is also really important because this is where you get access to your play menu, where you can play an editor and so forth. Moving forward, navigating in your viewport can be really quite simple if you've navigated three viewports before. You can use your mouse to navigate by clicking inside the viewport and using your left mouse button to push forward and back and side to side. You can use your right mouse button to orbit around the viewport. You can hold down both mouse buttons to basically pan around the viewport as well. You can also use your WASD keys to move around the viewport, just like if you were playing a video game. You can select an actor and hit the F key to frame in on it, and then hold down the Alt key to orbit around that actor. It takes a little bit of getting used to, but it actually becomes quite natural and very quickly. Once again, as I mentioned before, you have the ability to immediately jump into an Unreal Engine scene and play it in a live viewport. And you can do it in a variety of different ways. You can play the selected viewport. So just looking right into the editor, you can play that viewport, but you can also jump in and minimize the editor by playing an editor. That's called Pi, is what we call it. You can also play a standalone game, which means that if you've created an experience, you can completely get rid of the editor and play that experience as an executable, but you can also simulate the viewport, which does not possess the actual pawn, but allows you to play any kinds of physics simulation or any kind of particle systems or things that you want to actually experience without necessarily having to embody any kind of character that might be the player pawn that exists there. Now, if we start to talk about how to bring content into the engine, we call that the content pipeline. And one thing that's really important to note is that one Unreal unit is equal to 1 centimeter by default. And this can be really important because Unreal Engine is becoming more physically based at every turn. Our lights are physically based, our materials are physically based, our cameras are physically based, our physics is physically based. So this can be really important when working with your digital content creation tools. For instance, like Maya, Max, Houdini, Blender, any kind of tools, and to set those tools appropriately to make sure that you import your content at the appropriate size and scale. Importing content in Unreal Engine becomes really easy. You can use the import button right next to the green button in your content browser. If you've got the appropriate folder selected, which you can create by right-clicking and making new folders, you can import content directly into that folder by clicking on that import button, and it'll bring up a dialog box with all your import options. But another really easy way to bring content into the engine is to use drag and drop, which is supported both in Windows and the Mac platform. Another really powerful and amazing way is through the Quixel ecosystem. Quixel Bridge is a really powerful way to bring all the Quixel content into Unreal Engine, and it comes in with full materials if you choose to use those options and full textures completely applied. And you should be well aware that if you've got an Epic ID, the same ID that you use to log into the Epic Games Launcher to play games like Fortnite, you have full access to the full Quixel suite of tools and the full library that's available through Megascan. So you can get assets like some of these 3D assets. You can bring them directly into Unreal Engine with a click of a button just by loading the Megascans plugin into Unreal Engine. And this is a super fast and easy way to get very photorealistic content directly into Unreal Engine with a couple clicks of a button. Another very easy way to get really super high quality data from Rhino and SolidWorks, DeltaGen, VRED, and other architectural types and design packages is Datasmith. This is fully integrated into Unreal these days in Unreal Engine 4.24 and 4.25. Once you bring content into the engine, you can manipulate that content if it's a static mesh through the static mesh editor and the skeletal mesh editor if you're manipulating in the skeletal mesh editor. And there are a couple of things you might want to do to these meshes once you get them in here. Now, a couple things that you want to think about when bringing content into the engine is that sometimes you don't necessarily want to model all this minute detail into the engine. You have to remember that Unreal Engine only works with triangulated data. So you don't want to bring in quadrangulated data into Unreal Engine. You really won't be allowed to. It's going to triangulate the mesh. But you also have to remember that we track all the metadata. So just hovering over your mesh will expose all this particular detail. But you also have to remember that if you want to interact with all of this content into the engine, you're going to have to build a collision mesh, either in your external DCC tool, but be aware that in the static mesh editor, we have the full ability to create all the collision meshes directly inside the static mesh editor. By going into the collision drop-down menu, you can build all your collision meshes by using either simple primitives or using the auto convex collision tool to actually have those collision meshes generated based on the base mesh. You can also go into the mesh settings and actually use the actual visual mesh as your collision mesh at an additional cost. One of the other things that's important to note is that as you're working with meshes inside of the engine to optimize really large spaces, it can be really important to make level of detail meshes for them. You can also do this inside of your content creation tool, but Unreal Engine has the ability to make full auto level of detail meshes inside of the static mesh editor, and this is a really good way to optimize your projects. We also have the ability inside of the static mesh editor to make light map UVs, and this is really important if you're using pre-computed lighting models. This is something that you would do inside of your content creation tools, but now inside of the static mesh editor, we have the ability to generate light map UVs and control the full ability to separate all the light map islands and the UV islands, and full control of how many light map channels that you utilize. This is actually a great way to control all your light map UVs inside of the static mesh editor and not have to necessarily rely on doing that in your digital content creation tools. Now, not only do we import both static meshes, skeletal meshes using the FBX file format and USD, but we also import all the textures that you need. Now, there are some specific rule sets and guidelines that we like to use when bringing in texture data. We really need to control the way textures are used inside of Unreal Engine based on the physically based shading models that we're using. So we really require that all textures come in the power of 2. They don't necessarily need to be square, but they do need to be power of 2. And we support a variety of different file formats, including BMP, TGA, PSD, and for the compressed format, we use PNGs, JPEGs, DDS, and HDR formats as well. We manage a great deal of texture data coming into the engine, and we have to control basically the way these things get compressed and the way they also get MIPed. And this is really important because just like meshes have level of details, textures have level of details. So we don't always want to show the highest resolution of texture in front of you. As a matter of fact, as you move away from a texture, we want to reduce the amount of detail that texture shows to our cameras. So we actually compress all those textures and create MIPs for them all, unless you specifically define that a texture shouldn't have a MIP. In some cases, your UI textures, you don't want necessarily to MIP, or HDR textures used for cube maps, you don't necessarily want to MIP. So you can tell that in your texture editor not to MIP those textures. And you can see in this example that if you don't MIP your textures, sometimes that they can get really noisy. So this is a good example of why you would want it to ensure that your environment textures particularly get MIPed, because you can see on the right side here that unMIPed textures get really noisy as they start to get away from the camera. We also have lots of different view modes that allow you to see how texture MIPs are streaming at a distance to help ensure that it's working correctly. Now, when it comes to materials and material guidelines, Unreal Engine is a physically based rendering environment. We also call it PBR. And PBR is really threaded throughout the entire rendering pipeline. It removes the guesswork from authoring surface attributes, and it makes it much more predictable and accurate and visually consistent. And the way that it basically works is that you've got your non-metallic or your dielectric or insulator surfaces, and then your metallic and conductor surfaces. And so we use basically color that comes from diffuse and albedo. We've got our reflectance, which use Fresnel effects. And then you'll see that on our non-metallic surfaces, we basically have no tinted reflection. Whereas in our metallic surfaces, the color comes from the tinted reflection, and the reflections are subject to a Fresnel effect, but the tint is in the reflection. So this is a really important distinction that actually is a physical property that is inherited through PBR. Now, when it comes to building materials with PBR, if you start to think about the base building block of a PBR material, we basically look in the material system and see that we typically connect the base color with our albedo texture. We define whether a surface is metallic or non-metallic, and something that's important to realize is that this is usually a Boolean piece of information. Something is either metal or it's not metal, so this is usually 0 or 1 information. And we typically don't put texture information inside of this metallic unless it's black or white information defining that a surface has partial metallic surface or non-partial metallic surface. The specular is not necessarily used all the time because the roughness quite typically defines a lot of the specularity of a surface. It typically defaults to 0.5, and unless you're shading something like skin or translucent foliage, we sometimes don't even add attributes to the specular channel. But roughness is really quite important. Roughness is where a lot of detail comes into a material. If you think of something like black plastic, that can be really hard to illuminate unless you're defining that you want really shining black plastic, in which case you would put something closer to 0 for roughness, or something that's very scuffed up or rough, where you might put some texture data closer to the values of 1 to define whether it's more perturbed and has more micro abrasions closer to the spectrum of 1 for roughness. Of course, you also see that we've got more information that we can add here, like normal information, which gives us more surface detail, ambient occlusion, and depending on the shading models that you use, our materials can get significantly more complex. We have a very robust material editor, and the material editor is basically made up of building blocks, which include material expressions and material functions, and a lot of it is just math that goes together to build the information that defines a surface detail. All of that is translated into high-level shading language, which accesses a variety of templates which we have in the engine that define surface information. We take our materials and then in many cases we convert them to material instances. And one of the things that is a very common workflow is to create a series of master materials, and then from those master materials create another series of material instances that we apply to a variety of surfaces. And it is not uncommon to create, for instance, a master material for a car, for a sidewalk, brick buildings, and then create a series of material instances that we can use for the variance, for the variety of that content. Now, when it comes to lighting, there's a couple of things that are really important to think about and choose really early on. And that's whether our lighting models are dynamic lighting models or static lighting models. Because lighting and shadows can be calculated almost every frame, and they can be supported in many cases from the dynamic model as animated lights and objects. And so when we think about dynamic lighting, we really need to think about, well, what does it need to do? Does it need to change a lot? Do our object change underneath? If you think about the game Fortnite, it is a very dynamic lighting model because most of that environment is destructible. So if we don't use dynamic lighting, then anything that changes underneath would leave artifacts underneath. Static lighting model is exact opposite. We actually use pre-calculated lighting, And that lighting is actually baked into texture information and applied to the second UV channels to all the meshes inside the environment, to all those actors. This uses a lot less per frame performance, but it applies all of that texture information into the memory of that environment. So it's much more performant in a per frame perspective, but adds a little bit of overhead to the texture. And you also have to bake that information. So we actually do a calculation, a light mask calculation to do that lighting. Now, the way this actually works is that when you place a light inside of Unreal Engine, by default, all lights that are placed inside of Unreal Engine come in with a mobility setting, and this mobility setting is by default set to stationary. Now, if you wanted to go fully dynamic lighting, you would set the light to movable, and it turns it into a fully dynamic light. If you wanted to go pre-computed lighting, you would set it to static. And setting a light to static means that in order for you to be able to use that light and see it in the way that it would be as a final pre-computed light, you actually need to go to the build menu in the toolbar and build lighting. And then it's actually going to use light mask to build that lighting into the second UV channels of your meshes. And the same thing for all your shadows and global illumination. Now, stationary is a very unique lighting style because it actually does both. It bakes a static shadow into the static actors and static meshes in the environment, but it also, for instance, if you've got a character in the environment that needs to cast a dynamic light, will actually cast dynamic shadows for that actor as well. So if you think about a directional light, a sunlight, that you only have one in the environment, you may want that light to be a stationary light because you want to bake the static meshes to have pre-computed lighting, but then you want that same light to have a dynamic light for your character walking around the environment. So this one light type and this one lighting mobility type can serve both purposes. Now, stationary lights do have one particular limitation in that you can not have more than 4 stationary lights overlapping their influence at any given time, or it invalidates the 5th one. So for instance, if you have one stationary directional light and then you have, for instance, 4 more spotlights and their influence is all overlapping, one of them will become invalidated. So make sure that you're aware of that limitation. Now, the light types that are available to us inside of the engine are directional lights, point lights, spotlights, skylights, and rect lights. So of course our directional light is like a sunlight, something that you can place infinitely away. It's got rotational properties, but moving it will not influence your environment. You've got point lights, which is basically omnidirectional. It's like 6 spotlights pointing in every direction. You've got spotlights, which is unidirectional. It's got an umbra and a penumbra. You've got a skylight, which is basically your ambient light source. And basically creates a cube map, and that cube map can be used as, in essence, image-based lighting. And then you've got a rect light, and that rect light can be used, it has barn doors. You can basically use it to define width and height. And if you, for instance, want to cast illumination from a TV screen, or if you've got a big window and you want to amplify the illumination coming out of that window, you could put a rect light in that window and pump light into the environment through that. You can also use them for set lighting and things of that nature. Once again, I want to make sure that you're aware that if you're using pre-computed lighting and you want that to be baked into your environment, you need to make sure that all your meshes have second UV channels. And when you're making second UV channels, they can't overlap, those UV channels. They need to have adequate padding, or you end up getting what's known as shadow overlap or shadow smearing. And you can make them in your DCC app and import them. But we do have a really powerful tool for auto-generating those inside of the engine, and they can be auto-generated at import time. Now, another thing that's really important is reflections. And reflections can be really hard to calculate at real time. And we have 3 different types of reflections, all of which have their own pros and cons. The main three types of reflections that we have to consider, two of which are really kind of represented here and are kind of the same. We've got spherical reflection captures and box reflection captures, and these two are actually very similar in many ways. They're both fairly optimized reflection types. We use a lot of reflection captures, and you can use these pretty liberally in an environment. And one thing that's very important about reflection is that if you are in a PBR environment with PBR lighting and PBR materials, metallic surfaces, reflective surfaces just will not look right without reflection. This is one of the key tenets of PBR materials and PBR lighting. One thing that is present by default is screen space reflection. And this is something that you'll notice when you open the scene and move your camera around. If you've got like a reflective surface and you start to move your camera, and if you see the reflection start to peek away, it's because your screen space reflection no longer can capture it in your viewport. And if you place a spherical reflection capture and then build your reflections, you'll see that it starts to become more persistent. And the same thing is true with the box reflection capture. So a typical workflow is to place one large reflection actor in an environment and start to place more smaller reflection actors in that environment as well, because the smaller reflection actors tend to take priority over the larger ones. Now, the planar reflection actor is also very powerful, but it is significantly more expensive than the sphere and box reflection capture actors. But it's also really powerful for things like a mirrored lake or a glass mirror or something like that, where you really need accurate reflections, but it comes at a significant cost. Now, of course, ray tracing with dedicated ray tracing hardware like an NVIDIA RTX card is going to give you the most accurate reflections. And these are absolutely beautiful and stunning inside of Unreal Engine. They give you brilliant shadows. We have now, this is matured in Unreal Engine 4.25 with really proper denoising algorithms. And the reflections coming out of our ray tracing reflections as well as shadows are really quite stunning. So if you're really looking for high quality architectural renders coming out of Unreal Engine, this is going to be the way to go. Now, all of these systems really come together when we start to think about integrating fog into all of this. Specifically, if you think about our directional light, it specifically ties into our atmospheric fog actor to give us that air density and the light scattering that we really need. And one of the things that we typically see is that, we'll see lighting, and then if we don't see a fog actor, things really don't start to look right. Most recently in Unreal Engine 4.24 and 4.25, we've introduced a brand new sky atmosphere actor, which is absolutely beautiful and brilliant, that gives you full dynamic time of day, including sunrise and sunset. It's got a new atmospheric ray light scattering algorithm with My Atmosphere, and this is absolutely brilliant. And it can be tuned so that you can do full planetary curvature. Absolutely stunning. We also have fully updated our atmospheric height fog. It has a new high and low density. And this is also where you access full volumetric fog systems inside of Unreal Engine. So if you need volumetric lighting and volumetric fog inside of the engine, this is also really contributes to the photorealism of many of our environments and scenes. And once again, this is fully volumetric, and real-time volumetrics at 60, 90, 120 frames a second can be quite breathtaking. Now, I wanted to move really quickly into our in-engine blueprint system. I wanted to just iterate that blueprint and scripting inside of Unreal Engine is programming. It's node-based programming. It's compiled visual scripting language, and it compiles very fast. It's completely embedded within Unreal Engine. Users string together node connections that you can see the results instantly. It's like programming with Legos, and it contains many of the same features as a scripting language. Blueprints was designed to bridge the gap, to make programming appeal to those that are not professional coders, and it frees up engineers to keep working on low-level engine tasks. And over time, we noticed that blueprint devs were starting to think more like traditional programmers, and it really paves the way for non-coders to get up to speed with programming tasks and how it actually works. And it makes everyone able to prototype and develop systems inside of the engine without necessarily having to go to a programmer and say, hey, can you implement this idea for me? So it really liberated a lot of designers and artists. Now, one of the really powerful systems and things about Unreal Engine is that it is object-oriented. So you can create actor class blueprints of all different types, and they can really work within the framework and the hierarchy class of the engine, which is really quite empowering. And one of the really amazing things is that they can communicate with each other through a variety of different communication mechanics. We can use referencing, we can use casting, we can use blueprint interfaces and event dispatcher and delegates to be able to actually do things like, and I use a crude example. If you went up to a monitor and say, monitor on, you turn on the monitor. And, that used to take a lot of coding in the past. But, if you apply that same concept to anything else, if you went up to a fire and said fire on, then the fire's on. If you went to door and say door open, the idea that you can do that in a level, but do that and store that code and then do it at any level is where it becomes really liberating. Now, blueprints also have the construction script ability, which is like constructors in code, which actually add a great deal of proceduralism. And this is one of the ways that you can build tools inside of Unreal Engine to automate tasks, which also is very powerful. One of the most amazing things is that you can use C++ to expose functionality to Blueprint. So, for the programmers in attendance, you can actually very quickly and easily create Blueprint nodes, and almost anything can be made blueprintable in essence. And so it's pretty straightforward and easy. And we can do a lot of heavy lifting in C++ and expose it to artists and designers. And the workflow is really quite straightforward. Now, I want to really quickly talk about some of the visual effects tools in Unreal Engine. This is also recently matured in Unreal Engine 4.25. Niagara is an amazing tool set, which adds a great deal of modularity to our visual tool set. Each Niagara emitter contains multiple effects systems that can be used with lifetime, location, and size, particles that behave in a variety of different ways, and each independent actor can live inside of the level, but also can be built inside of the content browser, and they can share a lot of different systems within Niagara to build a lot of functionality and work with other systems in Unreal, like our animation systems, even our audio systems, material systems, and even our sequencer system, which is our linear animation tool sets. So one of the evolutions of our visual effects system is this modularity and our ability to create actors that can be placed and talk to each other similar to blueprints. So I really encourage you to take a look at the new Niagara system, which is breathtaking and quite powerful. Additionally, Sequencer is now 11, 12 versions old inside of Unreal Engine. Unreal is basically a tool that you can give full agency to the user to do anything they want. But Sequencer gives you the ability to have a linear timeline. So as we look at the interface of Sequencer here, you can see that it's not dissimilar to Adobe After Effects or Adobe Premiere. Or anything that has a linear timeline where I can bring a variety of different actors and cameras and audio, lights, and all different types of things into here, the tree view of Sequencer. And then I've got my timeline and my track views here. And I can put different things, including different subsequences into Sequencer. And I have a playhead that scrubs along here, and I can add a variety of different keyframes into Sequencer and animate along basically a timeline. And this is something that people are using throughout the television, broadcast, and film industry to make fully animated movies and films, and has really been embraced wholeheartedly by the broadcast industry and the media and entertainment industry and the event-based industry because of its ability to use the rendering and physically based photorealistic systems of Unreal Engine to do all kinds of amazing broadcast applications. One of the greatest powers that it outputs to a variety of different formats, including the ability to render out of all of our frame buffers. So if you want to render out any one of the custom depth passes, surface passes, ambient occlusion passes, any of that stuff can be output as separate render passes, including anything to EXR, JPEG, BMP, or you can just render out a whole movie out of it. Really powerful system, very worth exploring and experimenting with. You can animate just about anything inside of Unreal Engine within it, and there's much, much more to talk about. But my time is up now, and thank you very much. Once again, my name is Louis Cataldi. I'm education evangelist, and have a great Unreal Fest.